looking to the future a little bit. In episode 887 of this podcast, we had the global CTO of Dell, John Rose, on the show. And it's an incredible episode. He's an amazing individual and a really compelling speaker. Yeah, incredible episode 887. And in it, near the end, just like near the end of this episode, he talked a fair bit about quantum computing and how quantum computing is an inevitability. Just like you could see deep learning capabilities over time and eventually, you hit this inflection point where all of a sudden there's tons of real world applications that are commercially viable. All of that is, you could have modeled it for deep learning for years, decades in some cases, like Ray Kurzweil was. um, and John Rose says that same thing is now happening with quantum computing. Yes, today it is expensive. Yes, today there are not a lot of real world applications, but just look at the trajectory of where this is going. It is an inevitability that quantum computing will change the world in the coming decades. Um, how does quantum computing interact with mathematical optimization?
It's something that kind of gets in the way of people of doing optimization because for the main reason is there's if you've taken any sort of course or understanding of like sort of computational complexity and things like that, a problem complexity, which is I've been talking about of that a lot. You run across terms of like NP, P versus NP of problem types, NP hard, NP complete, all these types of sort of categorizations of decision problems that sort of show how hard it is to solve. And there's like this idea that if something has a certain label now in today's sort of computational world, that it is unsolvable and don't even try it. And mixed integer programming, which is again like the main sort of way that people, the main sort of model type that people use mathematical optimization for and Gurobi for, um, that falls into one of those super hard buckets. So people think it falls in a super hard bucket. The super hard bucket can't be solved today, so I need to wait for something like quantum. Um, and so there is this sort of misconception of that sort of that thought path that I just laid out. Um, what we're here to say is, okay, quantum computing, it may be an inevitability, it may not be. I, you know, I'm not gonna I'm not gonna sort of plant a flag on one side or the other on that. But what we do know is today is, yeah, it's not, and I think everyone would agree that it's not a viable way to really solve problems today. So if you're a CTO today or something like that, or CEO today or something like that, wouldn't you like to save a ton of money or be super efficient now instead of waiting possibly for the possibility of this happening in the future? So that's sort of like one of the hurdles that we're trying to get over is you could be doing all of the stuff that some of these quantum optimization problems are saying that will happen in the future. Like, oh, you can revolutionize your supply chain in the future with quantum. You could revolutionize your supply chain now with mathematical optimization. And here's what's really cool. Okay, let's say that in 10 years quantum optimization becomes the thing. You've already laid the groundwork. You're not starting from scratch. You're not missing the boat. You've the all of the things that you would need to do today to use mathematical optimization, understanding your business case, understanding all the problems that you can approach with this, all the ones you can't, understanding all the stakeholders, their involvement, getting buy-in, getting all sort of like the data connected to make sure that you're making the right decision with the right data going into your optimization model. All of that stuff needs to happen regardless of if you're using mathematical optimization or quantum. It still has to happen. So why not do it now? Why not get the benefits now? And then if quantum becomes the thing that some people think it's the inevitability, um, then you're just that much better prepared. You don't need to then, and if there becomes like this sort of rising tide of quantum, you'll know exactly where you are and what you can be doing. And then when you actually do sort of prototype or proof of concept quantum, you have a reliable benchmark. You have the right number that you should be comparing it to. You have an optimal state now, um, and versus what an optimal state could be with quantum, because sort of what the difference between that and what we can provide now and in the future, and what quantum would probably provide, is a lot more granularity, a lot more complex of the way that you model your problem down to like the nitty grittiest detail. Sometimes that can't happen with mathematical optimization now. Like if you're talking about a supply chain, you're not modeling individual workers and what they're moving, doing stuff like that. Maybe with quantum, that is something that you can do. You can get that extra granularity to help you really do things, or it solves like the problems that maybe take like 10 minutes or an hour to do with optimization. Now, maybe you are solving that in a second or a millisecond. So the whole thing is like, it could be, but why not get started now?